Hi, my name is Ron Ellis, and I'm here today to talk to you about maintaining a G7 print condition. G7 is great because it's all about color and not mechanical measurements. So today we're going to scan some press sheets, and I'm going to show you what those measurements mean. And then at the end of it, you'll understand how to use measurement to maintain your G7 print condition. Printing has always been a craft, but today's printers need to be more efficient than ever. That means continual measurement and constantly watching your print condition to see when it's changed. The idea is that instead of having the print condition change and having a crisis where you potentially lose a customer, you slowly see it moving, you correct it, and you're able to repeat the same thing day after day. So for the printers who succeed in the future, it's all about automation and efficiency, and measuring and tracking your print condition is a big part of that. There are some key metrics I want to look at when I'm looking at a G7 sheet. This sheet is targeted to Grackle, and that means I should measure against ISO solids, overprints, the NPDC curve, and gray balance. The first thing I want to do is look at gray balance. You'll notice when I click here, it gives me both the LAB values required, but also a visual display of how far off I am and what I need to do. Keep in mind with G7, the A star and B star scale for the paper color, and the Spectrodens calculates this for me automatically. So when I look at the sheet, I can see it's too yellow. And you can see how the DENS is showing me how to correct this. So looking here, those are my AB values. Up here, you can see it's telling me to add cyan and add magenta, which will compensate for the yellow. I can also see on this screen how my NPDC curve is doing in terms of the weight of the sheet, which is right here. So if you look right here, I'm a few points light compared to where my NPDC curve needs to be. Gray is not the whole story, though. Grackle depends on a few key components. Gray balance and the NPDC curve are part of it, but solids and overprints are another part. So I've switched my Spectrodens to ISO check mode, and I'm going to read my solids and overprints. So the first one I'm going to read is my cyan. And you can see in here when I take a look at it, I have my delta E. I have a checkbox saying that I'm within tolerance for the specification that I'm matching. And it tells me here that I can actually make this better by reducing 8 points of density, and that should give me a delta E of 2.8. So we're talking about the color of the ink here, and that's specified in lab numbers. And on this sheet, if I read through all of this, you can see that my colors are all passing except when I get to yellow. And if we look at yellow, we can see that it needs to be decreased, and it also predicts what delta E I should be able to achieve. So next I'll move on to the overprints. And the overprints are probably more important than the solids, because nobody accepts or rejects a job based on the color of the solids. The overprints represent the color. And while there's no ISO tolerance for overprints, Grackle does have a tolerance. So you can see as I read these that the CM passes. So you can see that there. That the MY passes. But the CY fails. And I can tell by looking at the lab numbers here, when I can compare them to my reference values, that I need less yellow to improve this trap. And if I check the MY one again, and I can compare this to my reference values, I can also see that having a little bit less yellow will make this trap even better. So the first thing I'll do is look at the density and make sure that we're at the target density. But obviously the paper we are on is having an effect of the color of the solid Y and the color of the traps as well. So I'll check my density. I can look up here, and I can see that I'm at a higher density than my reference. I can also see that my delta is out. This is called Gray Guide, and in it I can see density, I can see gray balance, and I can see delta E of the ink color. So I can see that right here. The second thing that I can do to check mechanical issues is take a look at the dot gain. So I'm just going to go into a density mode here. If I read a solid and just read a tint, it will automatically calculate the dot gain. And I can see the gain that I have here is high compared to my reference gain. Once we see the issue here, the press operator can go back onto the press and correct it. And based on what we saw with our quick analysis, if we simply reduce the yellow, it should pull the job back into compliance. I'm going to switch to gray guide again just to show you that. So you can see that it shows us being too yellow. It has us increasing the other colors to make it correct. Everything that we saw, the color of the overprint, the color of the solid of the yellow, and the docking of the yellow, show us that we have too much yellow, and by reducing that, we'll be able to pull the job back into gray balance and into compliance with ISO. So this was some quick hand reading, which helped us determine what was wrong with the sheet and how to fix it. And to get the most out of this, we want to get as much information as possible so we can see real time what's happening on the sheet, and also so we can watch for some trends on the sheet. The easiest way to do that is with a scanner. And you can see with a scanner how easily it scans the entire sheet. And when I do this, it captures the info from every patch on the color bar. Everything we measured on the sheet gets captured here in Espresso with one scan. And even better, we have multiple patches from the sheet here, so it's not based on one patch and on one part of the sheet. So applying what we learned a few minutes ago, we can quickly glance at this sheet and see what's up with it. Great. Well, I better go tell the press operator so he can take a look at his blankets. If you need more information on this, go to teshconusa.com.